Okay, here we go. So let's do some of these mole problems together. Now, here's our balanced equation. The question says, how many moles of O2 are used to produce 12 moles of water? So what I like to do is I like to write it underneath. Okay, so we know our starting number is 12 moles of water. So I'm just going to write 12 moles here. And I know that what I'm looking for is moles of O2. So I'm going to put question mark moles right underneath. Okay, so now this is a mole, one-step mole-to-mole problem. So I'm going to set up my train tracks. My starting number goes here at the beginning, just like always. So I had 12.5 moles of water. And in here is going to be my mole ratio. Okay, so whatever I'm looking for goes on top. So I'm looking for O2, so that's going to go on top. And whatever I start with goes on the bottom. So I started with water. Wait a minute. I'm looking for O2. That goes on top. Water goes on the bottom. Okay, so I can fill in what I know. So I'm going to use the coefficients from the balanced equation. So I'm looking for oxygen, so 2 moles of O2 goes on the top. I started with water, so 2 moles of water go on the bottom. Okay, and the way this works is if we've set it up right, our moles of water will cancel out, and we're left with moles of O2. Now, in this case, it's 2 over 2, so mathematically it doesn't change. So we can 12.5 times 2 divided by 2 is 12.5. So the answer is 12.5 moles of O2. All right, now let's do it again for the one below. Okay, so let's erase all this and let's see what we got here. This time the question says, if we start with 3.25 moles of CO2, so that's how much is produced, how many moles of CH4 were used? Okay, so let's go back to our balanced equation. Write what we know under the thing that it is. Okay, so we know we have 3.25 moles of CO2. So that's our starting number. And we want to find out how many moles of CH4 were used. So question mark moles under CH4. Okay, so now when we set up our train tracks, okay, our starting number is 3.25 moles of CO2. Okay, that's going to go there. Now, the other thing we need to do is let's think about, okay, what we're looking for goes on the top, so that's CH4, and what we started with goes on the bottom, that's CO2. Here we go. So, well, we're looking for CH4. So if there's nothing there that in the blank, that's a 1. Okay, so for every 1 mole of CH4 reacted, oh, there's a 1 as well. We produce 1 mole of CO2. That couldn't be easier because it doesn't change. So 3.25 times 1 divided by 1 gives us, you guessed it, 3.25 moles. Oh, so that's CH4, sorry. CH4. All right. Let's go on to the next page. Let's do the first one here. We'll do number 2, and then you could do number 3 on your own. Okay? So, same idea here. This is a mole-to-mole ratio. All right, so let's see here. What does it say? How many moles of calcium phosphide? So that's what we're looking for. Here's what we start with, 7.8 moles of calcium oxide. All right, we have a balanced equation. Let's not forget that if there's nothing there, that's a 1. Calcium phosphide. So let's write what we know. We don't know calcium phosphide, so that's our question mark, moles. And what do we know is 7.8 moles of calcium oxide. Okay, 7.8 moles. Okay, so now we have a roadmap here. This is our starting number. CaO is our starting number. Ca3P2 is our ending number. Okay. So let's set up our train tracks. 7.8 moles of calcium oxide. Now, here we go. Here's what we're looking for. That's going to go on the top. Here's what we started with. That's going to go on the bottom. All right. So our mole ratio, 3 moles of CaO. And what we're looking for, 1 mole of Ca3P2. So the mole ratio comes right from the balanced equation, and you use the coefficients in your balanced equation. So this time, we actually have to do some math. 7.8 times 1 divided by 3 gives us 2.6 moles of Ca3P2. My handwriting is bad today. So 1 more, and then I want you to do 3 on your own. Okay, so let's take a look at the last one. What does it tell us? How many moles of silver phosphide are produced if 5.3 moles of calcium oxide is also produced? Well, let's take a look. Let's reset our equation up here. I'm going to write down what I know. So I know 5.33 moles of calcium oxide. So that's going to be my starting number. What I want to know is moles of silver phosphide. Question mark, moles. Okay, so now when I set up my mole ratio, I'm going to be using the coefficients for these two substances. All right, so my starting number, as always, goes here. 5.33 moles of CaO. Now, my mole ratio. Oh, I gotta sneeze. Nope. Okay. So, down below is what I start with. Oh, I used the wrong color. Doesn't matter. Up top is what we're looking for. Okay, so let's go back to that. 3 moles of CaO. And on the top, what we're looking for, that goes on the top, 2 moles of Ag3P. All right, so our starting number, 5.33, times 2 divided by 3 gives us our answer, 3.6 moles of Ag3P. Okay, so your job. Set up the last 2 and solve them. I'm going to write the answers down here, but you won't get full credit unless you show your work. I want to see your train tracks and the whole deal. So for 3A, what do we got here? 15.5 moles of Fe. And 3B, it is 1.1 moles of Fe. All right, give it a whirl. I know you can do it.